Welcome to Maths with EJD. We're still talking about generating functions, and here we are focused on basic inversion formula for generating functions. Okay, so the inversion formula, we've been talking about this for some time. The inversion formula, again, helps us to recover the sequence from its generating function by relating the coefficients of the function to the sequence of terms. Okay. Um, Consider the generating function g of x g of x equals 1 over 1 minus x raised to power 3. Okay. Clearly, this is the same thing as 1 minus x raised to power minus 3. And if we expand that, that is equal to, so if we just go the usual way, right? We have 1 raised to power minus 3 minus x raised to power 0 over 0 factorial. Next, we have minus 3, 1 raised to power minus 4, that's minus 3 minus 1, then minus x raised to power 0. So that minus 3 plus 0 will give us minus 3 minus 4 plus 1. Minus 4 plus 1 will also give us minus 3. That has to be preserved. And then we have minus 3 minus 4, 1 raised to power minus 4 minus 1 minus 5, then minus x squared. So minus 5 plus 2 is also minus 3. This over 2 factorial, and all of that continues. So of course, the first one is always 1 because 1 raised to minus 3 is 1. Minus x raised to power 0, 1, 0 factorial is 1. Then here we have minus 3 minus x. That, of course, 1 raised to power anything is 1. 1 raised to minus 4, 1 raised to power minus 3, all 1. So this is now plus 3x. And next, we have 2 factorial. 2 factorial is 2. So 2 in 4 is 2. So we have 3 times 2, 6. Minus x squared is x squared. Minus 3 minus 2, that's minus 6. So we have that to be plus 6x squared, and so on and so forth. Um, so, I mean, the next one, okay, I guess if we go one more term, right, we're going to have, so let me just change the color and just see what we should have. That's good. That's going to be minus 3, minus 4, minus 5, 1 raised to power minus 6, then minus x raised to power 3, all over 3 factorial. 3 factorial is 6, so that's 3 here, 1, and here 2. So that's now 2 times 5. So the next one is going to be 10. So you see, we have a kind of pattern going on right there. So now you see this is 1. 1, so this is more like we have 1 x raised to power 0 plus 3x raised to power 1 plus 6x raised to power 2. And you see it's growing like that. So we have 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So that's 10x cubed. And it keeps going like that. Because, yeah, it keeps going like that. So the next thing we expect to have will be 10 plus 5, 15. That's 15x raised to power 4, and so on and so forth. So if you look at this as a whole, this is actually the summation from n equals 0 to infinity. So the coefficient is basically n plus 2 combination 2, then x raised to power n. So, such that when n is equal to 0, right, you have 2 combination 2, which is simply 1, and then you have x raised to power 0. Then when n is 1, you have 3 combination 2. 3 combination 2 will be 3, right? And x raised to power 1. Then when you have n to be 2, that means you have 4 combination 2. 4 combination 2 definitely is 24 divided by 2. Right? 24 divided by 2, right? So that is 6, and that goes on like that. So this is the general term for that. So g of x is equal to this, like that. So the coefficient now, the coefficient of x raised to power n is actually n plus 2 combination 2. Okay, so tells us this tells us that the sequence represented by this generating function is fn equals n plus 2 combination 2. That's the sequence we seek to extract. Okay, so if you take few examples, just like I demonstrated, for example, the first few terms are f of 0. So f of 0 will be 0 plus 2 combination 2. So that is 2 combination 2. 2 combination 2 is simply 1. So if you go f of 1, that is of course, we know f of n is n plus 2 combination 2. So that is 1 plus 2 combination 2. That is 3 combination 2. 3 combination 2 is simply 3. And then we can go f combination 2, which is 2 plus 2 combination 2. And that is 4 combination 2. 4 combination 2 is 4 factorial over 2 factorial, 2 factorial. That's 24 divided by 4. And that gives us 6. So, and it goes on like that. So we see that this sequence grows quadratically. Okay, so we see that right there. So whatever g of x we have gives us that. So at the end of the day, what the inversion thing is doing for us is that we are going to extract the coefficient. From the previous example I did here, that was very simple. The coefficient was always 1, so it's not changing like this one. So, but in this particular scenario, we actually have the sequence. We have the sequence changing. I mean, the sequence expressed as this, which we have extracted. So with that, we come to the end of this video. In the next lesson, in the next video, I'll be taking it a bit further, still talking about multivariate generating functions for solving complex systems, or maybe particularly in combinatorics, so we can have an idea how that really applies. Okay, so if you have not subscribed to this channel, you definitely know you'll be missing a lot. So subscribe right now and hit the notification bell so you can always get alerted each time a new video is released. For those who have subscribed, thank you so much. The number keeps growing and I'm so grateful. For if you can comment, of course, let me know how helpful these videos are for you. And also let me know if there's something you'd like me to teach, a problem to solve, a topic to teach, and share so that more people can have access to this great content. Till I come your way again. Bye.